Result and discussion. Result of QUAL2K are represented in a form of a graph as shown in this slide. The first graph with blue line color is the simulated result for dissolved oxygen, whereas the second graph with orange line color is the simulated result for biological oxygen demand for 2-month prediction period. From the graph, minimum and maximum value for water quality parameters can be determined. For simulated DO is between 1.3 to 5.6 mg per liter, whereas for simulated BOD is between 4 to 7 mg per liter. From this observation, it can be seen that during the 2-month prediction period, Likas River had exceeded the National Water Quality Index, where DO should not be less than 3 mg per liter and BOD should not exceed 6 mg per liter to maintain water classes of 3 as recommended by DOE. Another observation that can be made is where DO value decrease and BOD value increase at the first 2 reach. This can be due to headwater being close to the residential and commercial area, which is one of the primary location of point and non-point sources to the river. Then there is a sudden spike of DO value and decrease in BOD value at 7.4 km from downstream area. This may be due to the self-purification of the river, as there are no pollution being discharged at this location. And finally, there is a constant decrease in DO values and constant increase in BOD values after the 3rd sampling station until the point of downstream. This is due to the constant output of effluents along this segment of the river. This observation and analysis can be further clarified from the segmentation diagram of Likas River, where after the 2nd reach, there are pollution being discharged at this location which cause self-purification of the river, and there is constant output of pollutants from 5th until the coastal area that affect the values of DO and BOD. Moving on to calibration and validation process. This slide will be showing the example calculation of root mean square error for COD, chemical oxygen demand, of Likas River. The formula of RMSE is equal to square root sum of square difference between the predicted and observed data divided by the total cumulative value of COD for 5 stations. From the calculation, the RMSE value for COD is equal to 0.965, which fall between the acceptable range suggested by Henriksen.